Okay, hi guys, welcome to Biology Online with Henny van Vieren. Hi guys, welcome to our first YouTube lesson during this lockdown of 2021. I'm hoping that it won't last very long, but in the meantime, we are going on. Anyway, so just to remind you, the gas exchange surfaces, the things that make our gas exchange effective is that we have to have a large surface area, and we have to sorry, pointer options, laser pointer. We have to have a large surface area, the distance traveled has to be small, the concentration gradient has to be high, and your job, and also then moisture, your job is to compare how the different animals maintain a large surface area and also get a large surface area. So in other words, what protects it and what actually makes it big. The distance, how they maintain that distance, and how they actually get to have a short distance, how they maintain their concentration gradient, and then also how they maintain a moist surface. Okay, so I'm just going to jump through the next few slides. We said that fish live in water, and water is way less oxygenated than the air. The air has got like 21%, and water sometimes as low as. To get it out of the water, the fish uses gills, and the water goes into the mouth and out under the operculum. Okay, and that is how it flows through. So in other words, that's how it ventilates. Water flows into the mouth, through the gill rakers, and remember the gill rakers are there to protect the gills, just like our nasal hair and the hair inside the spiracles of an insect. Then it goes over the gills where the actual gas exchange takes place, and then out under the operculum. And we said that the operculum is a bony flap in bony fishes, and it is basically there to protect the gills from the outside. So let's say they swim into a rock or things like that. These delicate structures underneath need to be protected. Also, we want the gills close to the surface because water is really dense and it's difficult to ventilate, in other words, to get in and out. So the previous one, we talked about buccal ventilation, where it goes in the mouth and they actively pump it. Whereas now, we are looking at ram ventilation. And the ram ventilation basically is where the fish will swim with its mouth open upstream against the flow of water, and the water will simply flow in and out. Snapper and a lot of other fishes do it, and here you can see the bony arch, and that's an adaptation that gives the gills a structure, the support, and then the gill rakers are these bony mesh, I want to almost call it like a bony rake, that then prevents big things from getting into the gills, and if it gets into the gills it will actually damage the gills, and if it damages the gills we have a lower surface area or a smaller surface area. So that's one way that we maintain the big surface area. Again, we have the gill arch, and then we have the gill rakers there to protect. And on this side we have the filaments, and the filaments are the large projections or large or thicker hairs, if you want to call it that, but we don't call them hairs, we call them filaments. And that helps to increase the surface area, but to increase it even more, on top of each little filament we actually have lamellae. Okay, so that is what this diagram tries to show, is these projections of a filament. That's a single filament. I don't think it's a particularly great diagram. Again, you can see there's your filaments, and then these protrusions on the side is exactly where you will see, and that is how the fish gets an enormous surface area and maintains it as long as they are in the water. Because when you take them out of the water, all these things simply fall flat. While it's in the water, it flows and hangs around just like long hair underwater, but when they come up, they just fall flat. Okay, and then very important, we need to talk about counter current blood flow. So firstly, very large surface area, thin walled. Yep, the lamellae are only 2 cell layers thick between the actual outside and then one more cell layer to get into the blood. So it's a very short distance, and it's got a very high blood supply to bring the CO2 and carry away the oxygen. So bringing the CO2 from the body tissues and carry away the fresh oxygen that you just picked up from the water. Now when we look at a fish, and if you, for instance, have a fish, here's my fish, the water always flows in that direction. Okay, excuse my artwork, but I'm drawing with a mouse and I'm not really that good at it. So I should probably have the water in blue and make it a little bit, how do I make it wider? Interesting. Okay, it seems, okay, I'll do this. So the water always flows in that direction. Okay. Now, to maintain a very good concentration gradient or a favorable concentration gradient, your blood will flow over the gills from the back to the front. Okay, so we call that counter current blood flow, against the current of the water. Both currents are against or in opposite directions. And the way that it does this is that when the fish initially takes in, it's the freshest that it can possibly be because it's just come in through the mouth. But the blood it's meeting has been in contact with, has been in the gills for quite a while. And it's been in contact with water that is going in the opposite direction to the blood. So the water is 100% oxygenated, and let's say that 100% was only 4% of oxygen. Don't really worry about the numbers. But the point is, the concentration in the blood will always be lower than in the water. So the oxygen will flow into the blood. Now, this blood moves on, and now it's over here. Sorry, not the blood, the water moves on, and now it's over here. And when it's over there, it's actually in contact with blood that has spent less time in the gills than over here. And because it has spent less time in the gills, it has still picked up less concentration of oxygen in comparison to the water. So, because we have a favorable concentration gradient, the oxygen moves over. Our water moves on inside the gill, or over the gill. And it comes into contact with blood that has been in the gill even less time, had less time for diffusion. And consequently the concentration is lower still. So you see where I'm going with this. So because at the very end your water that has been in the gill for the longest time comes in contact with the blood that has been in the gill for the shortest time, therefore that blood that arrives here has just come from the tissues. And if it's just come from the tissues, then it has used up all its oxygen for respiration and energy. So consequently, it will have a very low concentration of oxygen. But this water has given off most of its concentration of oxygen. However, the concentration of that oxygen, even in this water that's been in there for a long time, is still higher than the concentration in the blood, and therefore it maintains a favorable concentration gradient. Okay, it's very important that you guys understand this. If you don't understand it, go read up on it and ask each other. Also, then you can ask me. Here's the diagram. You can see as the water enters through the mouth and exits through the operculum, your concentration gradient, even though the concentration of the water goes down, it remains above the concentration of the blood that comes in the opposite direction. Okay, I hope that makes sense. Another picture. Now remember, concurrent blood flow does not exist in nature. Therefore, and we've done this specifically so that we can see if it was flowing in the same direction, if you have the freshest water with the least fresh blood, or the blood with the least oxygen, very quickly you will get into a situation of equilibrium, and there will be no more exchange of gases, because equilibrium means it's equal on every side and there's no favorable concentration gradient. Whereas on this side you can see the blood entering the gill comes in contact with the water that's exiting the gill. So there's always this favorable concentration gradient. Okay, and this is Mr. Pollock's video. You can find it in the playlist that I've put on there on the YouTube for you, and you've watched it already. I don't want to be pinged for copyright infringement, but he's a very good teacher in my opinion, so you can definitely go and have a look at that.
Hi guys, it's Mr. Pollock.
There we go, the fish. And I will give you some written tasks to do, so we'll stop there for today, and then tomorrow we'll go ahead and look at mammals. All right, thank you guys, keep safe, look after yourselves, bye.